today, since I get to be last, I just have to get to cover all the things that have already been done, or I can just skip them. And so I'm going to skip them because there's so much good introduction that's been covered. I don't need to do it again. But really what I want to talk about is what AMD's been doing with Singularity. And we haven't done a lot, but as people have mentioned, we're involved in the industry. Some people don't even know we have GPUs for compute. We do, but what's happening is everyone's really excited about EPYC today. And EPYC's the CPU side of things for servers. And people are looking to put GPUs in these large servers, in data centers, in enterprises. And quite often they'll have a single or a dual CPU with lots of memory and some high-speed interconnects. You guys all know about supercomputers. Enterprises run small versions of them, but they also are looking to add the GPUs, and they'll have either 1, 2, or many GPUs. Even I've seen up to 16. We have quite a few platforms that have 4 or 8. That seems to be most common with a dual CPU, and 8 GPUs is a nice sort of balanced compute platform. And then you need a software environment that's configurable to be able to run in all those different workloads. So today we have already heard about the concepts of bare metal, virtualization, and containerization. So the key difference I want to show between these three here are the access to multiple GPUs in that environment. So it's not necessarily splitting a GPU. So that's one concept of virtualization, is taking one GPU, splitting it between different workloads. But this is taking 8 GPUs and taking 2 of them, putting it to one VM, or 2 of them putting it to one container, especially when a lot of the hardware now enables a flat memory model between all the GPUs. So you can access all 32 gigs of memory off of each GPU from any other GPU through interconnects. So NVIDIA has that, AMD has solutions for that. That creates other security nightmares that you sort of have to worry about. So just to give you a quick background on what AMD has is a compute platform. We've really focused on machine learning more recently. So that is a fully open source stack, right from the kernel device driver, math libraries, DNN optimizations, into supporting the main machine learning TensorFlow, Caffe2, and PyTorch frameworks. So we have upstream versions of those. We've upstreamed the kernel device driver, and people are building machine learning apps with that software stack. But first question we got when we started working with customers is, how do I build this? And there's 30 different libraries, and you need the special GCC version. So containerization makes a lot of sense in that environment where it's difficult to build. Some people spend just building TensorFlow for a CPU, and they'll spend days trying to make it work. So we've published Docker images for both TensorFlow and PyTorch. We keep those up to date. And then people are starting to use Kubernetes, and I'll go into a little more detail about that too. So after looking at Docker images, one of my colleagues added AMD GPU support into Singularity by forking the version 3 and putting in generalized support for GPUs. So you can go and see the actual GitHub components, and there's not that many changes, maybe 30 different groups of changes to say, instead of NVIDIA specific, it's GPU generalized. And that way, from the command line, you can do --rockem instead of --nv and get support for AMD GPUs. So we've already covered this today, but I'll mention again, it's all about compatibility between the host kernel and the user space components. So managing that backwards and forwards compatibility is tricky. We're trying our best, again, to maintain that ABI in the kernel, and as we upstream it, all the distros get that version, and the containers should run in any environment. C groups we mentioned, I'd like to have a little more discussion about what are the best ways to manage security for the different access to the GPUs, and as well as in the monitoring tools or debugging environments, as you cross those boundaries, how much of the access do you give to the different layers? It's important. Different customers want different access at like device driver register access points from a container, but that creates other security holes. So it's quite often it's usually security trade-offs that you have to do in these decisions as you build out the solution. So then in Kubernetes, we've built a Kubernetes device driver plugin. So that supports the AMD hardware. And you can take Docker images or Singularity images, also attach it with Kubeflow and make a nice machine learning environment. And one other sort of project we've been working on, and this is just a prototype of an idea, and it's to sort of help make those containers be more portable. And almost like the concept of a fat binary when you're building mobile devices, compile and target all the different options of devices you have in your environment, make one big solution, and then deploy it everywhere and have it figure out which hardware is there. So we have a prototype of it running. It'll support CUDA. HIP is the programming language for like our ROCm stack for accessing the GPU. OpenCL, as well as OpenMP. And so we're working on the OpenMP 5.0 as well. And this will target the many different CPU architectures. So in summary, we just want to say that we need to support a generalized support for GPUs. There's more people using GPUs for compute, but there'll also be other devices, not necessarily GPUs, but FPGAs or dedicated accelerators for compute workloads. And they'll run into the same problems as a GPU. So the GPU is a good example for following that architecture. And we're just happy to help and have more discussions with the Singularity community and work with experiments. We have a couple of students right now doing performance analysis on the EPIC side, and they're going to be moving to the GPU side to profile workloads for HPC. So any questions?
You've done the impossible. You got us back on schedule. Yeah. Well, despite my best efforts.
This is slightly off topic, but you were showing different GPU APIs up there, like OpenCL and things like that. In terms of OpenACC for AMD, it used to exist a while ago, and now that OpenSUSE is sort of putting their weight behind the GNU, GCC, and G4tran OpenACC compiler, is AMD sort of stepping in and trying to get an implementation in GNU for OpenACC as well?
We've talked about it, but we haven't planned it yet. It's, so I can't commit to saying that we have a solution or will do a solution. But it's definitely being discussed. Yeah, and that's another hard part is so many different environments that you can use to program. Right? It's be nice to consolidate a little bit, but.
I think Andrew's hand went up first, but it was pretty close.
I can yield.
You can yield?
Yeah, go ahead.
Guys,
Okay.
you got a race condition here. Come on, it's the end of the day.
I'm curious about the C group.
Yes.
Do we have this GPU C group now?
Do we have which?
GPU C group, or what's your?
I don't know. I just know my colleagues have, like you had mentioned, have been talking about what's the proper way, what's the best way to use C groups to create security for the GPUs. So we need to connect whoever.
Okay, yeah, I had my discussions with him, yes,
Okay.
in LPC a few months back.
Okay.
Okay, thanks.
Wasn't the same question?
Nope. No, I actually don't care too much about C groups. Sorry, maybe that's too opinionated, but I guess I'm trying to figure what's the best way I should advise my application teams to build a container that can run on, let's just say, any GPU. Should that be OpenMP? Should that be ACC? And then I guess I want to work backwards and figure out where's the right intersection level where I can just, what do I put in the container from a user level perspective, and then what do I let the system bind mount or worry about? Is that OpenMP?
I'd say it's still up for debate. From what I've seen, people have tried OpenMP. The newest 5.0 spec sort of covers a lot of the issues that we're missing in other things, but it's not available today, right? Like there's no real implementation you can deploy.
Okay. So, well, maybe this is a future thing that we could. There's also a Cocos project. If anybody's heard of that, I've got some Cocos containers I want to potentially try with this. So if anybody else is interested.
Yeah, Cocos is sort of like the framework for HPC, much similar to TensorFlow or PyTorch for machine learning.
So you showed that you've contributed basically that dash Rockham flag, right? Mm-hmm. Is that sort of a pending pull request then?
Yeah, I don't think it's a pull request. I think my colleague had just done a fork and then did a diff. It just shows all the.
Well, I mean, obviously, we'd love to continue to work with you on that. And anybody else? Quick show of interest. Anybody already working with AMD GPUs? Not yet. Like to be soon? Okay. Good. Okay. Yeah, interest. Okay. Excellent. Yeah. Well, and to so OpenCL is not the answer here. Yeah. Okay. No, I hear you. Yeah. Yeah.